Thanks, Kate, and thanks heaps for the opportunity to present today. I'd just like to acknowledge the Ngambri and Ngunnawal people whose land I'm on today, and acknowledge also the Warramunga, Wambaya, Wakaya and Wanyu people whose land overlies a lot of the rocks that I'll be talking about. And I'd also like to just modify my title a little bit, which is entirely my fault, because I'll be talking about basement geology between outcrop of the Warramunga and Murphy provinces. And I guess I'll be presenting stuff that's not just my work, but a huge amount of other people have contributed to this project at Geoscience Australia and elsewhere. You can find a lot of the information that I'll be talking about here on the East Tennant website. If you just Google East Tennant National Drilling Initiative, you should be able to find it. I'd like to thank the NTGS, a lot of NTGS staff who I've interacted with as part of this project. It's been probably a career highlight for me and a real privilege and blast to look at these rocks in the Northern Territory. And also the MINEC CRC National Drilling Initiative and OmniGeoX have really helped us with the drilling program, and pulling it off in the middle of COVID was a nice thing to have been able to do as part of this project. So thanks to everyone who's helped out. So just a quick intro to how we got into what we're sort of, or have called unofficially, East Tennant. This project started as part of the first phase for the Exploring for the Future program, which is a $225 million 8-year program. And the whole purpose of the program was to boost investment in resource exploration. And sort of at an early stage, it was decided to, before I started with the project, it was decided to have a bit of a focus area on what ended up being called the Tizer region, or Tennant Creek to Mount Isa region, and in particular seeing if we could collect sort of broader scale geophysical data to hone in on a potential prospective area in the region, which contains pretty prospective basement rocks that are where the intervening geology is overlain by younger basins. So can we use broader geophysical data sets to see through those basins? I'm just going to sort of skip through this pretty quickly because I'm not going to focus on, I'm going to more focus on the regional aspects of the project. So looking at the potential field data, in this case, magnetics and gravity, there's a lot of complexity in the image, but there's nothing that really sticks out between Tennant Creek and Mount Isa on the right. I've just highlighted a few interpreted faults, near surface faults from the magnetics data here. But once we start looking at some of these broader geophysical data sets that we collected as part of Exploring for the Future, the colours here show conductivity from Auslamp magnetotellurics data, which have been modelled up for a depth of 60 kilometres. And you can see there's the massive conductivity anomaly underneath Cloncurry, but there's also, can people see my mouse at all?
Yep.
Yeah, cool. There's also this kind of lower conductivity belt that descends to the east of Tennant Creek, and the contours here are the depth to the lithospheric asthenosphere boundary. There's a lot of error and sort of uncertainty as to the exact location of these contours, but nevertheless there's a kind of coincident gradient in the depth to that boundary, as well as this conductivity ridge and near surface faults from the potential field data. So those sort of three things really drew us into this area as potentially interesting from a prospectivity point of view, and that's why we were there. So to sort of start talking about the geological context and get into the nitty-gritty of the geology, the red circle here shows the location of the sort of the area of interest that I highlighted previously, and it sits between outcrops of the Warramunga province in the Tennant region to the southwest and the Murphy province to the northeast. The amalgamation of the North Australian Craton is sort of controversial, and I'll go into specific issues later on, but for now maybe I'll just state that it's worth stating that much of the Cratons is probably underlain by Archean crust, with most of the Craton between Mount Isa in the east and Halls Creek in the west assembled in the Archean there's not a huge amount of evidence for widespread tectonic activity, crustal shortening or magmatism, that sort of thing, between 2500 and 1900 MA across a lot of the Craton. But between 1900 and 1850-ish MA, the North Australia Craton records a deposition of a pretty remarkably widespread clastic succession with minor volcanism, with a really characteristic detrital zircon signature. And that's kind of shown in this diagram here, as you know, the Murphy metamorphics, potentially parts of the Tanami group, Warramunga Formation, Lander Rock Formation, this sort of stuff. And then between 1880 to 1830 MA-ish, a lot of the basement provinces, which are in dark grey on the map on the left, record deformation, moderate grades of metamorphism and magmatism, with the possible exception of the Aileron province, especially in the early phases of this kind of time period. And I guess the tectonic configuration of the Craton at this time is what's not particularly well constrained and a bit controversial, largely due to a lack of outcrop, but as well perhaps as due to intense reworking as a result of younger deformation, especially in Aileron province and Mount Isa Inlier. After around 1830 MA, deformation and metamorphism and magmatism were mostly concentrated to the south and east of the North Australia Craton and Aileron province and Mount Isa Inlier, which was sort of contemporaneous with widespread basin sedimentation across a lot of the rest of the Craton to the north, such as, you know, the McArthur Basin, etc. And I guess it's interesting to note the bulk of work undertaken, I think, on the sort of pre-1830 MA basement rocks of the North Australia Craton has been concentrated towards the ancient margins of the Craton, which are generally a bit better exposed as kind of the middle parts of the Craton. So understanding, you know, the rocks that underlie the middle parts of the Craton of that kind of 1850 MA age would fill a pretty significant gap in our understanding of the tectonic configuration of the Craton at this time, as well as provide additional insights for tectonic models for the Craton's evolution. Cool. So here you can see the extent of data and knowledge in the sort of East Tennant area. I've just zoomed in a little bit. You can see the Tennant Creek here is on the bottom left, Murphy Province outcrops in the northeast here, and the Warramunga Province outcrops down in the southwest. And the background image is just magnetics imagery. The colours here show where roughly pre-1810 MA rocks crop out. That's darker orange in this diagram onto the right. And these older rocks are more intensely deformed, metamorphosed to relatively low grades in general, and intruded by felsic igneous rocks. And older rocks, the oldest rocks are the Warramunga Formation in the Warramunga Province in the southwest, and the Murphy metamorphics as part of the Murphy Province in the northeast. They're shown in green on the map. And geochronology constraints indicate that both units were deposited around 1860 MA. They're interpreted as turbidite successions with local volcanics, similar to other coeval units across the North Australia Craton. They've got really similar detrital zircon spectra. And these units are interpreted to be deformed, have been deformed, metamorphosed, and intruded by granites, which are shown in the pink here at around 1850 MA. And that's termed the Tennant and Murphy events in the respective provinces. The metamorphic grades generally map to sort of green schist to sub-green schist facies. And in the Warramunga province, this event, as you all know, was accompanied by pretty significant copper gold bismuth mineralization. These rocks are unconformably overlain by sort of volcanic clastic successions in brown in the map, so Urujiji group in the Warramunga province and Cliffdale volcanics in the Murphy province. And with sedimentation sort of continuing with some significant time gaps into the larger intercratonic basins that cover much of the North Australia Craton, such as the McArthur Basin. And I guess it's worth noting that I think although it's been long appreciated that the Murphy and Warramunga provinces have a pretty similar geological history, the actual kind of tectonic or architectural link between the two provinces wasn't particularly well known. All right. So to the north and south of Tennant Creek, you can see, I won't talk about this too much, I'll just get straight into East Tennant geology. So for the next two slides, I'll kind of go through our interpreted solid geology of the East Tennant region. And I'll use that to sort of present some of the new data and stratigraphy that we've defined for the region in the context of rocks near Tennant Creek in the Tennant region. The red box just shows the extent of the new solid geology interpretation. So I've zoomed in here, and you can see the new drill holes as well as the existing legacy holes as part of this map here. And on the left is a plot of stratigraphy around Tennant Creek in the west. Just here, just for comparison, as I go through the East Tennant stratigraphy. So, and as we go through the stratigraphy, the colours on the strat column vaguely map the equivalent units, match the equivalent units in the map sheet here. So the oldest rocks in the area consist of tightly folded metapolitic rocks overlain by chemical sediments, potentially BIFs, carbonates with a few minor volcanic horizons or intervals. And the upper unit is especially anomalous for the Warramunga province. It's not really, these kind of lithologies aren't especially common in Tennant Creek, especially carbonates. It's only mapped as part of a single drill hole, but there are comparable lithologies in other drill holes which aren't dated. So it's potential that these units are a bit more widespread across the area than is currently recognised. And what's kind of quite interesting about these units is their detrital spectra and their maximum deposition ages. The overlying unit has a maximum depth age of around 1894 MA, which is significantly older than other units in the Warramunga and Murphy provinces. And the underlying unit has a really unusual age of max depositional age of 1970-ish MA. Which is and really unimodal for both of these samples. So that's kind of unusual for the North Australia Craton. I don't want to get too much into the tectonic interpretation of this more broadly, but it kind of, to me, confirms the idea, I guess, that there's not a huge amount of tectonic activity in the North Australia Craton in the sort of 100 to 200 million years leading up to that, the onset of a lot of activity around 1900, 1890 up in the north at least, and then sort of 1860 in the centre of the Craton. The East Tennant area is predominantly underlain by a package that we've termed the Alroy Formation. It's a widespread politic unit that's generally non-magnetic, but does contain sort of less common linear magnetic features, which are interpreted to be deformed stratigraphy. And yeah, we've termed this unit the Alroy Formation. The lithology varies predominantly due to metamorphic grade. In the extreme northwest and southeast, metamorphic grades, sort of sub-green schist facies, relatively low grade. And lithologies are comparable to the Warramunga province in Tennant Creek, with tightly folded banded siltstone, shale, mudstone, and phyllites. Towards the centre of the area, metamorphic grade increases to amphibolite facies, and schists and gneiss are more common. But the unit as a whole is probably deposited as turbidite, similar to interpretations of the Warramunga Formation and Murphy metamorphics. And that's, we've made that interpretation largely based on the lithology as well as the detrital zircon spectra, which are consistent regardless of metamorphic grade relatively, and they're also quite comparable to the Warramunga Formation and the Murphy metamorphics, albeit with some maximum depositional ages that are slightly older than what's commonly found in the Warramunga Formation. So I guess the takeaway message is that the rocks, the sort of main stratigraphic package underneath East Tennant is broadly comparable to the Warramunga Formation and other equivalent stratigraphic units in the Tennant region, as well as the metamorphic Murphy metamorphic, sorry. So there's interestingly not a lot of evidence for the Urigigi group or rocks equivalent in age to the Urigigi group or Cliffdale volcanics in East Tennant. There's a few little hints of things that are potentially this kind of like 1810 to 1840 MA age, but not a lot. So potentially that might indicate that we're exposing a slightly deeper stratigraphic or deeper crustal section in East Tennant relative to the west in the Tennant region. There's relatively minor our early interpretations of East Tennant is perhaps underlain by significant amounts of felsic intrusive rocks. Has generally been borne out by the drilling results. These rocks include the Elroy Formation, and there's probably similar quantities of intrusive material in the Tennant, in East Tennant as there are in the Tennant region and the Murphy and Lyre. You can see the uranium lead ages for the intrusive rocks in the time space plot over here, and that's just demonstrating that the rocks are pretty much identical in age to the Tennant Creek Supersuite and the Nicholson Granite in the Murphy province. There's not a lot of mafic units in the area. I'm not a geochemist, but from what I sort of understand, the geochemistry is not really compatible with subduction activity. And there's a few indicators that are vaguely comparable with subduction, but I think the lack of a negative titanium alloy involved neodymium isotopes signature suggests that trace element patterns that may be indicated an indication of subduction probably instead result from assimilation of crustal material. A large granite in the southwest of the area is geochemically identical to the Tennant Creek Supersuite, which has been included within. The remaining felsic intrusions we've termed the Mount Lamb Suite. I won't go into the geochemistry of those, but I don't think it's particularly, the geochemistry doesn't particularly distinguish strongly any kind of tectonic setting. It is the main takeaway point, I think, that has been extracted from geochemical data of intrusive rocks in the area. As I said before, there's a few slightly younger units which might be equivalent to the Orogeny group or Cliffdale volcanics, but we've interpreted Orogeny group to mostly be restricted to the southwest of the area down here. Although there's not a lot of data in the southeast as well, so potentially there's a bit more Orogeny group down there. But yeah, it's quite striking how these slightly younger rocks are generally lacking in the area. Cover depth increases significantly to the north and to the southeast, so we've avoided interpreting these rocks other than to assign them to the Warramunga province general. And then we have the overlying post-1810 and 80-ish basin stratigraphy, excluding the Georgina Basin, which is shown here, that covers the whole area. So I won't get into that any further. And now I just want to talk a bit more detail about deformation and metamorphism. So the image here on the left is sort of a simplified cartoon of pre-Georgina Basin geology in the area, showing the Warramunga province in the Tennant region in East Tennant and the Murphy province in the northeast. And the image on the right is the same time space plot as before, but expanded to include the Murphy province. So I'd just like to focus and zoom in on this more exciting period of geological history from around 1870 to 1830 I'll zoom in on a bit. And this plot shows all the available uranium and geochron data for the 3 basement areas, at least when I compiled this plot a year or so ago. And so, as it's sort of currently termed, the Tennant region, and I guess unofficially East Tennant form part of the Warramunga province, whereas the rocks that crop out in the Murphy and subordinate Carrara Range in Lyre in the northeast are included within the Murphy province. In terms of deformation, prior to this work, deformation and metamorphism in the Murphy and Warramunga provinces were generally interpreted to have occurred together broadly at some point between 1855 to 1840 MA, and we were kind of expecting in this program to demonstrate a pretty similar relationship or a situation in East Tennant, and call it a day. We dated some monazite from metamorphosed Elroy Formation at East Tennant, an enigmatic amphibolite facies rock near Tennant Creek, and the Murphy metamorphics, and got some kind of interesting results which prodded us to look a bit more closely on the timing constraints on deformation in the Warramunga and Murphy provinces themselves to explain these data, which I'll kind of go through now. Just southwest of Tennant Creek, there is this package of amphibolite facies metapolitic rocks that, as far as I know, as of yet haven't been undated. We just had access to a thin section from Dave Constant's PhD from a fair while ago. So that had monazite in it, which we dated. You can see a photomicrograph of a garnet biotite magnetite schist, this thin section, which is a pretty anomalous metamorphic grade for the Tennant region. These rocks have been recorded or reported to have been intersected in several drill cores across at least several kilometres. So the metamorphic grade and the extent of the metamorphism is much greater than the recorded extent and grade of contact metamorphism surrounding the kind of higher level intrusives at Tennant Creek, which are reported to be several hundred metres, green schist facies, sub-green schist facies features. Within these higher grade rocks, there's a moderately developed early fabric, which I've labelled S1 here, which is associated with peat metamorphic minerals, including monazite, and it's overprinted by a more discrete shear fabric, slightly lower grade, which I've labelled S2. And so monazite associated with the early fabric here grew at 1858 plus or minus 7 MA. And you can see just in the time-space plot here, ideally the error bars on this would be a slightly smaller. But the timing of peat metamorphism, which we've interpreted from these data, probably predates a lot of the intrusive rocks in the Tennant region. And this deformation metamorphism is probably unlikely to have occurred during the deposition of the Warramunga Formation. So it's potentially constrained to this sort of 1860, 1855 MA time period. And that's also consistent with the Yukon-Tanana Formation and sort of equivalently aged units that overlie these rocks, which are interpreted to be less deformed than the underlying Warramunga Formation. So, collectively, these I guess observations and data point to an episode of deformation and metamorphism in the Tennant region between sort of 1860 and 1855 MA. Intrusive textures in the Tennant Creek supersuite suggest relatively passive emplacement at shallow levels, but the intrusions themselves exhibit often weak penetrative fabrics or more intense discrete shear structures, which kind of indicates that deformation in the Tennant region also occurred or continued after the emplacement of these rocks between 1855 and 1845 MA. I guess the key constraint which I've interpreted to provide an upper or lower limit on this deformation is argon data associated with some of these younger structures, as well as mineralisation in Tennant Creek. There's considerable uncertainty on these ages when you take into account the uncertainty on the decay constants, and that's been documented well by Fraser et al. Reinterpreting some of Dave Compson's PhD data, and that kind of constrains this younger episode of deformation to have occurred prior to around 1830 MA, but most likely around sort of 1840 MA ish. So considering the data available overall, I think that makes the most sense that shortening began in the Tennant region at around 1860 MA, producing folding and low-grade metamorphism in the Warramunga Formation and higher grade metamorphism in deeper units, ? And we've sort of termed this D1, and that's this episode here. And then this was followed by probably extension and exhumation, leading to the emplacement of the high-level Tennant Creek supersuites and its extrusive equivalents, like the Yukon-Tanana Formation, prior to renewed textile transpression based on interpretations by Nigel Donnellan at around 1840-ish MA, and that's this event here, and this was sort of the main episode that drove mineralisation at Tennant Creek, and we've termed this episode D2. And I guess it's been interesting to watch the evolution of data coming out of the rover field, and I'm not quite sure whether the deformation there is interpreted to be slightly younger than this. Potentially this deformation here is slightly younger as well. So it'll be interesting to see how that kind of relationship develops as that work in the rover field continues. So as we go to East Tennant, there's also quite a bit of high grade or a medium grade amphibolite facies rocks in East Tennant. The metamorphic grade here is probably a result of extensive magmatism and the exposure of a slightly deeper crustal section, but the metamorphism is definitely associated with or characterised by the development of a steeply dipping regional fabric, which we've termed S2 for reasons I'll get into, and that appears to overprint a slightly lower grade, poorly preserved fabric, S1. So in the top here, you can see the sort of not very commonly preserved relationship between intrusive rocks and a sort of composite S1, S2 foliation. So this relatively steeply dipping fabric in the Alroy Formation is cross-cut by less deformed melt bands, which still parallel that main foliation. But these bands, you can see in the thin section on the left, are then cross-cut themselves by a sort of continuation of that development of that fabric. And these melt bands grade into relatively massive 1850 MA intrusives. And I guess this is a pattern that's sort of continued from thin section to drill core to map pattern, where you have intrusive rocks that probably cross-cut an earlier foliation, but are themselves wrapped by or cross-cut by ongoing foliation development. And sort of overall, this is a comparable relationship to the relationship between deformation and magmatism in the Tennant region, where the intrusive rocks are kind of bracketed by what we've interpreted to be relatively discrete deformation episodes. Due to the elevated metamorphic grade in East Tennant being associated with later fabrics, it's often difficult to find well-preserved evidence of earlier structures. So here's a rare example from a rock in the southeast part of the area, which is slightly lower grade. And you can see relic graded bedding here in this image, and that's there's folding of that, tight folding of that, which is associated with a fanned cleavage we've termed S1, and that's overprinted by a low to medium grade S2 shear fabric. And there's no direct constraints for the timing of any early episode of deformation, which we'd call D1 at East Tennant, but its position along strike of D1 structures in the Tennant region suggests that East Tennant was also affected by this episode of deformation. And an episode of shortening, or at around 1860 to 1855 MA East Tennant, is also provides a convenient contribution to the subsequent generation of widespread intrusive rocks at East Tennant. So we've kind of inferred that this episode of deformation occurred at East Tennant, but it is largely inferred. And monazite associated with a later, more high-grade overprinting S2 fabric elsewhere at East Tennant grew at around 1845 MA, and this age was remarkably consistent and pretty tightly constrained across the three samples that returned precise ages for monazite at East Tennant. And it's slightly younger than many of the intrusive rocks in the area, but identical to the younger D2 deformation in age that we kind of talked about in the Tennant region to the west. I won't go into the details of evidence for the timing of deformation in the Murphy inlier, but there's fairly robust textural and overprinting evidence that indicates that Murphy metamorphics were tightly folded along broadly east-west striking axes, implying sort of north-south crustal shortening broadly, at around 1860 to 1855 MA, prior to the emplacement and eruption of the Nicholson granite and the Cliffdale volcanics, which are sort of depicted here. And this is pretty much identical to what's recorded near Tennant Creek and probably also at East Tennant. And so we interpret this event as part of that D1 event. An interesting result from part of this work was identifying a second episode of deformation in the Murphy province, which we've interpreted based on monazite ages from a foliated amphibolite facies rock in the Murphy's metamorphics, where we got a age of 4 plus or minus 3 or 4 MA, which is identical to the timing of D2 in East Tennant and in the Tennant region. So these two sort of deformation episodes, like in the Tennant region, bracket the emplacement of pretty voluminous felsic intrusive rocks and colloidal volcanics. So considering all these observations together, although there's a bit of inference going on, it seems like we can identify an early episode of broadly overall north-south directed crustal shortening, D1, which affected all three of these regions at around 1860 to 1855 MA. This followed by widespread felsic intrusive activity and exclusive magmatism, and potentially driven by an episode of extension following earlier crustal thickening during D1. And then ongoing deformation. I know that this information has been interpreted to have resulted from geochronology in the Tennant region. Potentially it's equivalent to what's at this point, but this episode of deformation continued within the tightly folded stratigraphic package of now relatively hot rocks, producing more discrete shear structures with an elevated metamorphic assemblage, at least in the more deeply exposed East Tennant region. Yeah, and so I guess overall the takeaway message here, which we've interpreted, is that the Warramunga and Murphy provinces appear to contain a east or northeast trending tectonic magmatic corridor that developed between 1860 and 1840 MA, although it's sort of worth noting that the northern and southern boundary of this corridor are not well constrained. So how much it is actually a corridor, I guess, remains to be seen. And how far it extends to the east or the west is also pretty uncertain. So just to finish up, I'd just like to wave my arms a little bit and talk a little bit more about potential implications for the development of the North Australia Craton. And I guess this tectonic magmatic corridor that we've proposed here comprises a pretty big chunk of the central part of the North Australia Craton. So I think it's important enough to be considered or to have implications for some of the regional models for the development of the Craton. It's also interesting to note that this 1850 MA feature has largely been preserved. So it's, it hasn't been really heavily impacted by later events in the Aileron province, the Mount Isa inlet, that sort of thing. So hopefully it's a bit of a useful piece of the puzzle to consider when attempting to recreate tectonic architecture of the Craton at this time. So if we look at some of the proposals for tectonic architecture of the North Australia Craton at around 1850 MA, it's these two examples on the left. There's one from Betts et al. And Lee et al. On the right, and it's kind of difficult to reconcile the first order features of these models with that kind of east-northeast trending belt, which is at a fairly high angle to a lot of the first order features in these models, especially the model on the right that has a pretty significant north-south break or convergent margin between Tennant Creek and Tanana areas at this time. I guess if we look at our belt in the context of magnetic imagery of the Craton, you can see the northern coastline of Australia here and the eastern and western boundaries of the Northern Territory on this magnetics image. It's kind of tempting to interpret the belt to continue west, potentially north of the Tanana origin, which doesn't contain intrusive rocks of this age, at least that I'm aware of. And then if we sort of conveniently ignore Halls Creek and Mount Isa for now and consider data from the Pine Creek and origin in Arnhem Province, as well as the Tanana origin in Aileron Province, there's a pretty nice north to south transition in the timing of deformation and magmatism. And obviously this isn't a new observation at all. I think many people have pointed this out, but I think the identification of significant 1850 MA tectonomagmatic domain, as part of the Warramunga and Murphy provinces in the Tennant region and the Murphy inlier, kind of adds a fair bit of weight to this model. This idea of north to south younging being a key characteristic of tectonic development of the North Australian Craton between 1880 and sort of 1790. And I think it has a lot of similarities with a model proposed by Dave Maidment and others in 2020 with potentially the main tectonic driver of deformation and metamorphism between 1880 to 1855 MA being a convergent margin to the north of the current boundaries of the Craton. There's several issues though. Suzanne Schmidt and others have documented some pretty compelling evidence for subduction at I think around 1900 MA in Tanana origin, so finding a subduction zone or attributing that to a subduction zone far to the north is potentially a bit too far. And that sort of argues for potentially a convergent margin somewhere a bit closer, whether that's Halls Creek or south of Tanana in the shore. Also, I think there's issues with the orientation of structures between Arnhem and Pine Creek generally being north-south as opposed to east-west, which would be more consistent with this kind of broadly southward migrating tectonic magmatic activity. And also what's going on in Halls Creek and Mount Isa are potential issues here, which I'm not an expert on, and I don't really want to get into right now, but potentially the slightly younger age of those events allows for this model to still be kind of valid, and those events just overprinted on its eastern and western margins. But that's all I wanted to talk about today. Sorry, I was mostly reading off notes because I just wanted to make sure I sort of have a relatively complete list of things to say, because I've put this together relatively rapidly over the last week or two. So I'm very happy to take any questions or comments. Thanks.